gone through countless cycles before our own Big Bang, each one leading to a new cosmic beginning. Instead of a singular beginning point, time might stretch infinitely in both directions, with each Big Bang being just another phase in an eternal cosmic heartbeat. One version of cyclic cosmology, called the ekpyrotic model, suggests that our universe is the result of a collision between higher dimensional brands in string theory. When these brands collide, they release an immense amount of energy, creating the conditions we recognize as the Big Bang. This means that before our universe, there could have been another, existing in a different state before collapsing and giving rise to our own. This concept challenges the traditional understanding of time and existence. It implies that what existed before the Big Bang wasn't nothing, but rather an earlier version of the cosmos, one that underwent destruction before being reborn. If this is the case, then our universe might not be unique, it could be just one in an infinite sequence of universes, each one emerging from the ashes of the last. Conclusion. The question of what existed before the Big Bang is one of the greatest mysteries in science. Theories ranging from inflationary multiverse to cyclic cosmology, quantum fluctuations, and dark energy all suggest that something, whether an endless cycle, a vacuum filled with energy, or even an unseen cosmic force, preceded our universe. While we may never fully uncover the truth, one thing is clear: the idea of nothingness before the Big Bang is far more complex than it seems. As our understanding of physics advances, we may come closer to answering this profound question, revealing not only the origins of our universe but also the deeper nature of reality itself. The search for evidence. As fascinating as these theories are, the challenge lies in finding evidence to support them. Since we cannot directly observe what came before the Big Bang, scientists must rely on indirect clues embedded in the cosmic microwave background radiation, CMB, gravitational waves, and quantum fluctuations. One potential lead is primordial gravitational waves, ripples in spacetime that may have originated from the inflationary period before the Big Bang. If detected, these waves could provide insight into what caused the rapid expansion of the universe and whether something existed beforehand. Advanced telescopes, such as the James Webb Space Telescope and future observatories, aim to capture remnants of these signals. Another approach involves studying quantum fluctuations in the CMB. Some physicists propose that tiny irregularities in the early universe might hint at conditions before the Big Bang. If our universe emerged from a previous cycle or an inflationary multiverse, subtle imprints could remain in the cosmic background radiation. Philosophical and existential implications. Beyond the scientific quest, the question of what existed before the Big Bang carries deep philosophical and existential weight. If the universe had a beginning, does that imply a cause or an external force? If time itself began with the Big Bang, can we even ask what came before? These questions touch upon the nature of existence, consciousness, and the limits of human understanding. Furthermore, the possibility of a multiverse or eternal inflation raises profound implications. If countless universes exist beyond our own, each with different laws of physics, what does that mean for our place in reality? Are we part of an infinite cosmic landscape, or is our universe truly unique? The journey continues. As scientific advancements push the boundaries of our knowledge, we inch closer to unraveling the enigma of what existed before the Big Bang. Whether through new discoveries in particle physics, breakthroughs in cosmology, or revolutionary theories that challenge everything we know, the pursuit of this mystery remains one of the most exciting frontiers in science. While we may never have a definitive answer, the journey itself expands our understanding of the cosmos and our place within it. Perhaps, in exploring the unknown, we will discover that the universe is far more mysterious and wondrous than we ever imagined. Being reborn from the remnants of a past universe, the process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning but rather an eternal series of universes emerging, growing, and renewing themselves over and over again. Cyclic cosmology raises significant questions about time, as it suggests that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was just another version of the universe, one that collapsed only to give birth to our current universe. For researchers, this theory offers a rich answer to the question of ultimate origins, proposing that there is no true beginning. The universe has always existed in some form, transcending our ideas of time and existence. Early-stage gravitational waves are another intriguing idea that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in spacetime caused by massive cosmic events, and scientists believe early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as the echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous states. The potential discovery of early-stage gravitational waves is one of the most exciting possibilities in cosmology today, as it might not only reveal the truth about the Big Bang but also offer a glimpse into the cosmic state before our universe was born. This theory offers a tantalizing prospect, detecting gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what could have existed before the Big Bang, we delve into concepts that push the boundaries of our understanding, challenging even our most fundamental assumptions about space, time, and existence itself. One of the most mind-boggling ideas comes from the realm of quantum gravity, a field that seeks to merge quantum mechanics with general relativity. This merger could potentially reveal a unified theory of everything and might offer insight into what existed before the Big Bang. Quantum gravity suggests that space and time are not smooth, continuous entities as we experience them, but instead are discrete, granular structures. This theory posits that the fabric of spacetime itself could have been formed from a microscopic Planck-scale structure, with tiny quantum fluctuations shaping the universe in ways we cannot yet fully comprehend. In this view, what we perceive as the smooth continuum of space and time might have only emerged from these fluctuating quantum fields. Thus, the period before the Big Bang could be described by a radically different concept of reality, one where space and time themselves were not fully formed. Another possibility is that the universe is part of a vast cosmic landscape of possible universes, each with different physical laws and constants. This theory, known as the string landscape, arises from string theory, which suggests that all fundamental particles are actually tiny vibrating strings. In this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is just one of many, each emerging from its own distinct Big Bang-like event. The existence of such a landscape also brings forth the notion that other universes might have different dimensions, different strengths of gravity, or even different types of matter. In this view, our universe might not be unique but rather part of a multiverse, a collection of universes, each evolving independently. The multiverse theory provides a speculative yet fascinating answer to the question of what came before the Big Bang, another universe, in a different configuration, potentially leading to infinite cycles of creation and destruction with no definitive origin. In addition to these cosmological models, some theoretical physicists have also considered the role of black holes in shaping the nature of the universe. A hypothesis gaining attention is that our universe could be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe, with the Big Bang being the moment when such a black hole gave birth to our cosmos. This hypothesis is supported by the fact that, according to general relativity, the singularity at the center of a black hole is a point where space and time curve infinitely, creating a region where the known laws of physics break down. It's possible that the extreme conditions inside black holes could lead to the creation of new universes, which may suggest that what we consider the Big Bang was just the birth of our universe from the singularity of an ancient black hole. Exploring these concepts requires a deep dive into the very nature of time itself. Some cosmologists speculate that time as we understand it may have had no meaning before the Big Bang. If time began with the Big Bang, then there may have been no before in any conventional sense. According to this view, time itself might have emerged from a quantum fluctuation or from a primordial state where the usual distinctions between past, present, and future did not apply. This could lead us to rethink the concept of causality, which relies on the assumption that events happen in a linear sequence. If time did not exist in the way we experience it, then the question of what came before the Big Bang becomes nonsensical, as there would be no temporal framework to support it. Further complicating the picture are theories of cyclic time. As mentioned previously, cyclic cosmology suggests that the universe undergoes endless cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent just the most recent bounce in an eternal series of universe cycles. These cycles might not be identical but could evolve in different directions, each with unique physical properties. The cycle of the universe, according to this theory, would be a continual process with no true beginning or end, rendering the question of before the Big Bang meaningless in the conventional sense. The idea that time itself might be cyclical suggests that every Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. Another avenue of investigation into the nature of the cosmos is the potential existence of a primordial soup of particles and fields that existed before the formation of stars and galaxies. This concept suggests that before the universe began its rapid expansion, it was filled with a dense and hot mixture of elementary particles, including quarks, leptons, and bosons, all in a state of extreme energy. These particles would have been interacting at very high temperatures and densities, laying the groundwork for the formation of matter and energy. As the universe cooled, some versions of this theory suggest that this primordial soup existed in a quantum foam, where particles constantly emerged and vanished due to the uncertainty principle of quantum mechanics. The properties of this soup could potentially offer insights into the universe's earliest moments and, by extension, what preceded the Big Bang itself. Ultimately, what existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics deepens,